Other examples are race car too, right? Correct? Right? If I write something like that, is it a palindrome? This is not, right? This long string is also another palindrome, right? Anita lava latina, right? That's another palindrome, right? It's the same both ways, right? So, I'm sure you have worked with this example before, right?
No.
Back into Java 1? No?
Not at all.
First time I even hear about it.
Sorry?
First time I even heard about it.
Really? First time you like to hear this? Really?
No.
For us,
Word palindrome?
What is it that
I didn't do it with Recursion, I did it with Q.
Q's. You
Yeah.
can do it with the stacks as well. But, okay. You have seen that Gregory in my Java 1 class, remember? You should remember. Okay. So the idea is that you receive a string. You receive a string S. Okay, so you have a string S. It can be any of those, or it can be anything. Okay, it can be your name, Carlos. Your job is to take this string and determine somehow if it's a palindrome or not. Return true if it is, false if it is. Got it? There are multiple ways of doing it. The guy at the back is saying he did it with Q's. Some people might solve it with stacks. You don't know that yet, right? But you can solve it so far with two ways. Iteratively, with a for loop, and what else? Recursion. Okay. Which one do you think we need to know now? Recursion, right? The solution iteratively is a cake. Very, very easy. Okay? There are multiple ways of doing it, of doing this iteratively. One solution, I'll tell you one solution. If this is a string S, okay? People say, I will have string S2, initially empty. And you know, sorry? Okay, okay. Guys, stay silent then because otherwise I'm going to speak over you. So you put S2 equal empty string, okay? And one way of solving it is say, I will try to form into S2 the reverse of the string. Meaning that if the string, say for example, is car, the reverse would be rat, right? I'll try to build and store the reverse of the string S into S2. After that, I'll compare S and S2. If they match, then it's a palindrome. If they don't match, then they are not a palindrome. Got it? So how can you do that code? Well, you have to grab from the last character all the way to the first character, right? How do you do that? For loop. Int I equal, last position is 0? No, last position is not 0. It would be S length minus 1, right? That's the last position, right? And you want to go, bless you, and you want to go all the way until the first position. I greater or equal to 0. I plus plus, right? Correct? Sorry, I minus minus, right? Because you're going down. Right? So this will allow you to go here, 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 until it wants to go negative, and then you stop because you cannot go negative, right? Until you're greater or equal to 0, right? And then you will say S2 equal S2 plus S char at I. Correct?
Yeah.
That will finish. When this loop finishes, S2 will be the reverse of S, right? The next thing you need to know is just this. S equals, ignore case, or just equals S2. Then you return true, because it's a palindrome, for example, else you return false. Got it? Simple? Okay, right? Easy, right? Copy that, guys. Quick. You shouldn't need to copy if you did that in Java 1. But probably the professor did not cover that in Java 1, right? Thank you, professor didn't cover anything. Huh?
You said length minus 1?
Couldn't hear you.
On the for loop, you
It
said
says, well, from I equal S length minus 1. That's the
Minus
last
1.
position, right? The last position all the way to the first position, 0, right?
okay, correct.
Do you have to check it going plus plus and then minus backwards?
No, because remember, you have an original string, S. What I'm doing is building S2, which will be the reverse of S. So I'm grabbing the last character from here and putting it at the top here. Last character, You understand what I'm saying?
Are you going from back to front?
Yes, that's how I build the reverse, right? If I, for example, your name is Vito, V-I-T-O, simple. So I want to grab the last character, O, then I want to grab T, then I want to grab I, and then B, right? So that's the idea. And then compare that with the original. Yes, sir?
It says for the first one, it says integer I equals s length minus 1, semicolon, I is greater than or less than 0.
Yes, while I is greater or equal to 0, because remember, it's going to go like that until it reaches 0. Then when I becomes negative, you don't have any position in the negative, that's when you stop, right? Your last value position is 0, right? Yes. S chart at I will give me the character at position 9. I need to concatenate that with the previous string. I need to form. Remember, for example, let's play with Vito, the small string. Okay? Initially S2 is empty. Right? Here it says S equal S2 plus this. So I say S2 equal S2 plus the character at position last one, which is O. This is empty string, the first time, right? So far S2 is O. Then this will go one less, so I'll grab the T, right? So I say S2 equal S2 plus T. S2 from before was O. And it's becoming OT now. Got it? Otherwise I will lose the first one. If I don't put this, if I just do this, if I do it without this circle one, then I will just say S2 is the last character. That's it. But I want to put all of them together again. Right? That's accumulation. Yeah. I just don't like using those short form stuff because I'm getting lost. That's supposed to be. Is that clear, guys? Yes? This is one simple solution. Okay? Can I erase? No. All right, another solution there then, when you're copying this one.
What is the bottom line?
At the end I'm saying, if S is equal to S2, then I return true. It's a palindrome. Else, so you don't even need an else, return false. What's another solution? If you have something like civic, for example, okay? Or even if you have something like Vito, just 4 characters, and you want to check if this is a palindrome. What you can do is, I'll go from 0 all the way to half the string. Right? And as I am here, I will check the last position. So I will check this guy against this guy against this guy. Got it? Right? Yeah. As soon as I find a mismatch, I know it's not a palindrome. Is that clear?
Yep.
Is that clear? Now, if there are no mismatches and if everything matches, when do I stop? Check this out. If I use a string like this, let me put something random. A, B, B, A, A. This is a palindrome, right? This guy matches with this guy, then this guy moves here, this guy moves here, right? Correct? Then this moves here, and this moves here. Let me use blue here for this pointer and black for here. Now, blue moves here, black moves here, right? If I don't have anything to control this, what will end up happening is that they will overlap, and blue will be here and black will be here. And that would be stupid because these guys have already been checked before, right? Correct? Again, I'm still going with iterative solutions, and I'm doing that because you didn't do that in Java 1, even though you're supposed to have that. So, what I can do is have 2 positions, right? Pos 1 and pos 2. Pos 1 initially 0, right? Correct? And pos 2 is S that length minus 1. That's the last position, right? And I will keep comparing them while what? While pos 0 is less than pos
1.
Well, it's less than pos 2, right? When pos 1 is less than pos 2, I keep comparing and moving them. Because when they overlap, now pos 1 is bigger than pos 2. And that doesn't make sense, they were already checked, right? Is that clear? So it only makes sense to complete checking them when the black is smaller than the blue. Because when the black becomes bigger than the blue, that means that I'm overlapped already, and that's not necessary, that's already checked, right? Is that clear?
Yep.
So I can do just a while loop here and say, while pos 1 is less than post 2, right? All you do is just compare, right? Start comparing, right? Say if S char at post 1 is different from S char at post 2, what happens if the character at position 1 is different from the one at position 2? Then it's not a palindrome anymore, right? It's not a palindrome, right? So you say return false. Correct? You don't need to check anything else. Do you need to keep checking? No. As soon as you find a mismatch, it's over. No more a palindrome, right? Correct? Else, you don't need anything else because you have a return here. What you have to do is keep checking because that means that they were equal, right? So you keep checking. What do? You move post 1 to the right and you move post 2 to the left. Right? Hold on one second. When this loop finishes, this loop can finish for two reasons. Because this return happens, meaning that it's not a palindrome, and you get out of the method, right? Or this loop can finish because post 1 happened to become greater than post 2. If this happened, it's because everything matched, right? And I should be here, right?
Yeah.
So if I'm here, it means that I finished because an overlap was about to happen, so everything matched. So I should return true, because it's a palindrome. Any question? Well, this should be inside a method, right? Public boolean check palindrome, check pal. You receive a string S, and that's it. Yeah, now you have the whole method ready, okay? You guys maybe have a hard time doing that. Any questions? No? And this should also be inside a method, right?
What if B is C
So that-
instead of B?
So that's your return.
Hold on one second, one at a time.
So what if the second B is a C? How does it check?
What if the second V is a C? What if this guy is a C?
No, the BB, if it's BC, how do you check?
You want to put a VC here?
Yeah,
That's fine. Here still post 1 is smaller than post 2, so that comparison will happen.
oh, it's still smaller,
Yeah,
okay.
it's still smaller.
Okay.
Now, some people like putting greater or equal here because they wanna check, for example, the word say, let's say CBC, for example, right? Here and here, right? At one point they are both on the same one, right? And they wanna say, yeah, they wanna compare that, but that doesn't make sense. If you're comparing the same, it's gonna be true anyways, right? So you don't really need the equal. But if you put equal, it still works. You got a question, somebody here?
No, I was just gonna ask, kind of like the same question. If you get that matched, you get a return true, correct? Like, if they're both B, I mean,
If everything matches, yes, I
Right.
return true.
okay.
So I'm going like this. I should have used here blue from the very beginning. So let me start from scratch. Black represents post 1.
Right,
Post 2 will be represented by a blue arrow,
the whole line.
right? Correct? Post 2 is the last position. Length minus 1, that's the last position. Remember, the length minus 1 because you're starting with 0, right? Now, I ask, is post 1 less than post 2? Yes, the black is smaller than the blue. The black is 0, this guy is saying, I don't know, whatever it is. 3, 6, 8 should be 7, right? Position 7. 0, 1, 2, 3, 4, 5, 6, 7, right? Correct? Got it? So post 2 is 7, post 1 is 0, right? So is 0 less than 7? Yes.
Yes.
So what I do is I compare. Is the character at position post 1
Right.
is A different from the one at position 2? No, they are not different, they are the same.
Would you put there, S dot check at?
S that char at post 1. Char at. This is like the third time I'm using these guys. You should be practicing, okay? You should be familiar. Char at a given index gives you the character at that position. Like, we have done that already. So I'm saying, if the character at position post 1 is different from the character at position 2, then don't do anything else, return false. Like if this were F, A is equal to F, obviously not, so you would return false.
So in
Is
this
that
case, you
correct?
get a true.
Is that correct? Yes, because you don't need to keep checking, right?
Right.
In this case, they are equal. Do I have to return true? Not yet.
Not yet,
Why? Because I
they
need to
have to
keep
continue.
checking, right? So I will come here and say, okay, there was a match. Let's keep moving. Post 1 plus plus,
Increment.
post 2 plus plus. So now my black arrow should be here, and my blue arrow is minus minus, so it should be here.
I see, yes.
Got it?
I see.
Clear?
Yes.
Right?
I got it.
Eventually, I'll get to this point. post 1 is less than post 2. But since both are growing, after this comparison and having a match, B against B is a match, I will make this guy plus plus, right? And I'll make this guy minus minus, and I will have this overlap. In this case, post 1 will no longer be smaller than post 2, correct? So this condition will break. Post 1 is no longer smaller than post 2. That means that everything matched, and therefore I got an overlap. Therefore, the loop breaks, and I should be safe to say true. Got it? Simple, right? Now, which one do you like better, guys? Which way do you think is easier? This one seems easier? Might be easier, but it's more inefficient too, but anyway. So let me put this how it will look in a method, okay? It will be public, boolean, say check val.
Why don't you put it on the computer?
Because it takes longer time. You should do it in the computer though. If something goes wrong, you ask me. Got it? That's how it should look in the computer as a method.
Does it say public, boolean, and then check?
Check val, whatever you want to call it.
So the other one we said was more efficient. If we use a word like civic, that's not evenly distributed, it has one guy on another word.
Doesn't really matter. Doesn't really matter. Because it's strictly equal. So the one in the middle will not be checked. It doesn't really matter. The one in the middle can be anything. Right?
Can be anything.
It can be anything. So yeah. Look, it's a civic, right? Can this guy be a P, a T, an F, a D? It's still a palindrome, right? Got it? Doesn't really matter. When it's odd number of characters, the one in the middle doesn't matter. When it's even, everything has to match. Right? That was your question also, I think, right?
Oh, yeah, just to say that was more efficient.
That is more efficient, yes, because that one is not using an extra string variable.
Yeah,
So it's
I know.
waiting memory. Okay, guys, you have to try this. If you want to try this in the main, this method would have to be static here, and, right? Because the main cannot call a method if it's not static. Unless you want to put it in another class and it's a sheet and all do that. Okay? So put that in the computer. Now we all agree on what is a palindrome, right? We all know what a palindrome is, and we know how to solve it iteratively, right? Any solution, either this one or either that one, is an iterative solution, okay? Now, the question is, how can I build a method similar to this check val? Let's call it check val recursive if you want to, that returns a boolean that giving a string can return if it's a palindrome or not. Now, you have two options, okay? You have two options. What are they? You can just receive the string S and figure out how the heck to do it recursively. That may be complicated. So, what normally you do when you want to think of a recursive solution, especially at this stage where you are still kind of doubting, is think of a solution that you understand perfectly, iteratively, that could become recursive. And that will give you an idea of maybe extra parameters that you might need besides the string S. Where do you see something growing or decreasing? In which solution do you see something growing or decreasing?
This one?
This one broke.
That one, right? Correct? That one, right? You have the post 1 and post 2, right? And when do we stop? In that one? When post 1 and post 2 overlap, or when one is greater or equal to the other one, right? Now, doesn't that look similar to a stopping condition? That's when we stop. So you could assume that somebody gives you a string S in post 1, comma post 2 the first time. Okay? And you say, look, if post 1 is the first position, right? And post 2 is the last position, right? What's the simplest case of a palindrome? A string of what length? 1, right? When a string has 1 character long only, right? A very small string, that's a palindrome, right? So what would you say? If post 1 is equal to post 2, then I return true. Correct? If somebody gives me post 1 return? True as well. If there is an overlap, it's because everything matched. Remember? So my stopping condition could be as simple as if post 1 is greater or equal to post 2, I return true. Else, what can I do? I have two options. The string is not small anymore. The string is big. Right? Correct? Now, what do we do with a bigger string? Can I give an answer for the whole string? Recursion tells me no, you cannot. So what I will do is simple. Check the one at post 1, check the one at post 2. If there is a mismatch, say, return false. Else, what do? That means that these guys match. I should call recursion, but now post 1 moves and post 2 moves. Isn't that similar to that one? I'm pretty much tweaking that solution to become recursion, kind of cheap. Right? Do you understand that one? Yes? Do I have to write it? I mean, it's not to your benefit, guys, because I write that means I give you less examples for your exam. So that's fine. Yes, sir.
So if the equal, the else, we should just change the position for each one?
What do you mean? What I'm saying is I will keep moving like this. When they overlap, it's because it's an odd number of characters, like civic, right? Like civic. I'm here, right? I'm here, right? But here, since it's both are going to overlap, right? And that is the same situation as if I give you just a string of just one character. The last one and the first one are overlapping as well. Either this case or either this case, it means it's a palindrome, right? That's what we were talking about. Now, if I give you post 1 here and post 2 here, they overlapped already. So it's a palindrome. So if everything overlaps, because it's a palindrome, right? That's what we saw there already, right? So that's what we're going to do. Now guys, I was telling you, and we're going to provide two positions, right? First position and last position. What is the last position? I think I'm faster typing it, right? Now, I was telling you that if you wanted to write any of these solutions, then you have to put the word static. That's the only thing you have to change here, right? Not too much to us. This is what you have to write. Static. Okay? The rest is the same. Okay? And let's call it check file. I call it check file recursive, right? String, S, and always you're providing two positions. Post 1 and post 2, right? Sorry? I like that before, right? I don't know what's wrong with that. Okay, let's see. Oh, my bad.
Oli?
I didn't specify what you return. Okay, so I said, if post 1 is equal to post 2, it's a one character string, so it's a palindrome. So I should return. It's important to see if you were paying attention. Or it's less or equal, right? Like if there is less or equal, it's also. So if this happens, if post 1 happens to be greater or equal to post 2, there was an overlap, right? So it's true also, right? Okay. Else two things can happen. If S char at post 1 is different from S char at post 2, I should return false. I don't need to do anything else, right? Correct? Else, I don't need to put an else because there is a return. I need to return check file. I mean, there was a match, but I need to keep checking, right? Of this guy, now to move this guy and increment this guy.
Why in the second decision not equal to char hat positive? Why is it not equal to?
If two characters, if character from here and here do not match,
Oh, okay.
then it's not a palindrome anymore, right?
Sure,
No
okay.
need to take any paragraph.
Okay.
In this case, Anita Baratina is a palindrome, but if you change something like whatever, then it's no longer a palindrome, right? It will tell you false. Correct? You can try anything. Okay. Is clear? I'm running out of creativity. This is a fine exercise to do. I know of one. You were thinking about last class, how to calculate the sum of an array, the sum of the elements in an array. Oh, actually, no one. Binary search. Yes.
What?
It might take some time though, but I think it's a good idea. You know what binary search is, guys? Have you ever heard that?
Yeah.
What is binary search?
The search algorithm that you have to have the array sorted first, and then it starts like cutting half. And it checks for that, thing that index they were looking for, or that.
Okay. Yeah, what Carlos is saying is pretty much it. You want to search for something, for some piece of data, and you don't know where it is. So you're performing, like, you're discarding part of it. Let me show you a clear example where you use binary search. Imagine in the old days where you were looking for somebody in your contacts, you didn't have your cell phone. So people would write contacts in an address book, right? And the address book was sorted by alphabet, right? Say last names with A, then with B's, then with C's, right? So somebody tells you, I want to look for this person whose last name is, say, Morales, okay? So that's M, right? So you make a guess and say more or less Morales should be in the middle, right? So what you do is you open the address book in the middle, correct? Now, what if you open letter F? Now, what do you say? It should be to my left or to my right? To my right, right? So do I have to do anything with this half that is to the left of F? Maybe it's 200 pages that I'm saving, right? I don't need to check there anymore, right? So we'll go to this second half. And again, maybe I'll open it in half. Maybe I will land in P, right? Now I know it should be between the half from where I initially opened and P, right? It should be to my left, right? Not to the right of P, right? So you understand what I'm doing, right? Every time I'm reducing the problem half, 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 right? That search is much faster than if I do a sequential search. If I do a sequential search, I have to go letter by letter, blindly. And it takes much longer, right? If you do computer science, you will learn about time complexities. That would be a time complexity of logarithm of n, because every time you're splitting it in half, 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 half. Okay? Yes?
Would something similar to this be find Newton's method?
Sorry?
Newton's method to find the intersects of a graph? It's essentially you're finding the tangent and repeating it over and over again until you find the intersect.
And as soon as you find a mismatch, you don't have to keep going, right?
Yeah.
Similar. It's very similar. Okay? But the classic approach is that one. That one is the one that everybody has used, everybody is familiar with, right? You go by half, and if you don't find, you go to the other half, right? Correct? But if you remember, that requires to have the elements sorted. Because if you put Morales at the beginning and say Alvarez at the end, then everything is messed up, that method does not work anymore. You have to do what? A sequential search. You have nothing else to do, right? Correct? So binary search requires that the array is sorted previously. That's why I don't want to play with array A, because I don't need to sort that one. I don't want to sort. So I'm creating this array, say B, that is sorted, right? Ascending order, right? Does it have to be ascending? It can be descending. But if you do it descending, then your algorithm has to change. Sorry?
No, for descending.
Descending can be done too, but then the algorithm will have to change. The greater then those symbols will have to change. Okay?
Can you show us how to do it?
I'll show you how to do the binary search. Okay. What would be the best scenario?
That it's on the first in the middle, directly in the middle, half here and out here.
So you need to know what's your start and end, right? Your start and end positions of the array, right? So I need to have extra parameters, right? Binary search. Oh, I'm stupid. I'm not putting binary search. It should be false. Otherwise, why did I use the variable, right?
Yeah.
First position. I need to know the first position. What else?
The last, which is B half the same. Minus.
Okay, so we start and end, right? Or left and right. Whatever you want to call it, say left and right. Right? So here you play your medium position, right? Mid, right?
Yeah.
Would be what? Left plus right over 2, right? Correct? You would be lucky if you open the book and you arrive exactly where you want, right? So the best scenario is that B at position mid is equal to what you're looking for. Well, I'm missing something here. What am I looking for? Element, right? That I want to look for, right? Let me put a number. What number do you want to look for? 798. Okay? It's there, right? To return a position, right? Here what? In search, for example, right? The element in search, right? Correct? Then I should return true. True? Not really. I'm going to return the position where I found it. In this case, me. Right? That's the position where I found it, right? Else, what happens?
You check if the.
You wanna repeat that?
Okay. This is what happens.
Less than or greater than.
Can you let me use it? Okay, to make it very clear. Okay, imagine this is the address book. What I have done is I have opened this in the middle, like this, right? And I have checked. Oh, it's the person I'm looking here. Right here, say Morales. Is it here? If it's there, then I say, okay, this is the position where I found it, right? Page, say, 200 something, right? Now, if it's not here, what do I do?
You wanna check if it's left or right, where you.
I want to check if I have to look here, or if I have to look here, right?
Right?
How do I know? If I arrive on P, that means that I went too far ahead. I need to look on this first half, right? So you have to check if the element in the middle,
It's
right,
greater than A? Or
is bigger than the element I'm looking for.
Yeah.
If the element I arrive, which is the one in the middle, is bigger than the element I'm looking for, I should look on the
Left.
left. Is that clear? Here you go, see. So I will say if, right? The element, say if the element is in the middle, right? Is greater than the element I'm looking for, I have to look. The result will be doing a search on B from the very beginning, right? From the same left, but up to the middle minus 1, right? Correct?
B is the array.
And the element is the same, search, right?
Okay, what's the right 0 and then?
Else what? Where do I need to do the search?
Right. So you would say from the mid to the end, which is the length. Yes.
I should go from the middle plus 1
And
all the
then-
way to the right that I had. Is that clear? Yes? Is this perfect? Close to perfect. Something is missing. Are we ever contemplating here a return false?
Yeah, we need to return, somehow to return.
What happens if the element is never there? What problem could we have?
Then it's not found, right?
We can analyze that with a small array. Okay? This is sometimes complicated to figure out how that happens. So what you can do is think of a small array of this size. 3, 0, 1, 2, put elements, 7, 9, 12. Say I'm looking for 13. Obviously, we'll never find it, right? So initially, mid is 0 plus 2 over 2. Mid is 1, right? I say, let's say the array is B. B of 1, is it equal to this? Obviously not. So I'll make a search, a binary search, bin search. I'll make a binary search on B from the middle plus 1, from 2, all the way to the last element, which was 2, right? And I'll look for 13 again, right? Here, what will I do? I'll say mid, I'll determine mid again. 2 plus 2 over 2, 2, right? Is B of 2 equal to search? No. B of 2 is 12, is not equal to 13, right? Now, are you bigger or smaller? This is smaller. So I'll try to make a search on the left. I'll make a search on the left, right? So I'll make a bin search of B, right? From where? I want to make it on the left. From the same beginning to the mid minus 1. Mid minus 1 would be 1, right? Can left be bigger than right? Can left be bigger than right? That doesn't make any sense. Right? You understand what I'm saying? Left has always to be smaller than right. Correct? But here we have detected that our search is looking to 1.
So you just check it.
So if left, you start noticing. This happens because of why? This happens because the element is not there. That's why we're sending a binary search from 2 to 1. Does that make sense? That doesn't make any sense, right? Correct?
Yeah.
I cannot search from 2 to 1. Is that clear, guys? So how do I detect that the element is not there? When my left is not smaller than my right. My left has to be less or equal to my right. Correct? Clear? Yes? So? I can make it here. If left is greater to my right, then just return false. This is one approach. Okay? Another approach. Some people don't like this way. Some people say, I'll do this, all these checks inside, if left is less or equal to right. And they put all this like that.
So it only do research.
Only do all this work, otherwise just return false because that doesn't make any sense. Got it? Not return false, my bad. You're turning a position, -1. -1 always indicates that it's not there, right? The search gives you an invalid index, right? This search tells you the index where it is found. If it's starting -1 means it was never found. Any index, right? Correct? Yes, sir.
I'm not understanding what's going on, kind of.
Sorry?
I'm not understanding what's going on, how you're doing that.
The last part?
Yeah.
Okay. I'm saying, you understood all this chunk, you understood it perfectly, right?
More or less, yeah.
Okay. The problem is when the element is not found. I was writing here. Say this is the original array. Okay? And this is the element you're searching for, 13. Well, you can visually see that it's never going to be found. It's not there. So the method should return -1, because position 0, nor 1, nor 2 have it. Right? -1 will indicate an invalid index, so it's not there. Right? But how do I discover that I should return -1? So I will try to do the search according to my algorithm, right? So left 0, right 2. You understand that, right? The first time. Look at here. Left is 0, right is 2, right? So mid will be 0 plus 2 over 2, 1. Got it? Is that clear?
Yeah.
So I will check if B of 1, the one in the middle, is equal to the element I'm looking for, because that's what it says. If the element in the middle is equal to search, return the position in the middle, because that's where you found it, right? Look at this part.
Because you're trying to find the middle.
You always try to hit and see if you're lucky. Right? When you just open, you want to check if that's the element you're looking for. Correct? The one you just landed. Right? So I'm saying, is the one in the middle equal to 13? No, it's 9. It's not 13. Right? Is 9 less or bigger than 13? It's smaller. So I have to look on my right. Correct? So I'll make a binary search on my right. From the middle, plus 1, right? Which will be 2, all the way up to the current right. So we'll go from 2, 2. Will be a binary search on 2, 2. This is my left, this is my right, and 13. Correct? Correct? Now, if I was looking for 12, I would land to a result immediately here. But anyway, so I'm saying from left, right, and 13, right? Correct? This is clear. Correct? Binary search on B, 2, 2, 13. So far, so good? Yes? So middle, 2 plus 2 over 2 is 2. Right? B at 2 is 12. Correct? Is that element equal to my search? No. So is 12 less than 13 or bigger? It's smaller. 12 is smaller than 13. So I'll try to make a search on the right side. Right? Correct? So I'm saying go from B. The starting position should be the same, but the other position should be one less. And here you discover your problem. Because this doesn't make any sense. Left can be bigger than right, so it doesn't make any sense.
It's 12 is less than 13. If 12 is less than 13, then it would fall into mid plus 1, not mid minus 1.
Okay, maybe I made a mistake there. Okay, I think you're right. So I'm saying if 12 is smaller than 13, right? So I should go, the start should be the same. Right? Start. No. I have to go from the middle plus 1. So it will be 3, 2. The end should be the same. Now I'm out of index. So then, yeah, that's another scenario. The other scenario was if you go to the other side, right? So here actually we have a different problem.
So R goes automatically to number 2 because you moved up to the right.
Correct.
It changes. How
You
can,
only change the start or the end, depending if you're looking to the left or to the right.
how does R change in the code? How do you see that? How will it change automatically?
Hold on one second. And both are in range, right?
If the B comes 0, B down,
In pause, you mean, right?
You can say
position.
Yeah. What are you talking about? What are you?
you want both
What
to
is
be
that
inside
B
range.
comes
If one of them goes outside range, it's wrong.
B is the array
Right?
he initialized on the top. 0 is
How do you check
the
if
start
something
of the
is inside
array.
range? That is
0
correct.
is the left. Is the left starting position. B dot length minus 1 is the right. Well, yeah.
Okay, regardless, both have to be inside range, right? I'm going to put the B comma next here, specify that next. So I have to make sure that L is greater or equal to 0 and that L is less than length, right? So for it to be in range. And the same with the other guy, right? And the same with R. Hold on one sec. Hold on one sec.
Now I don't know what he's saying. This is tough.
Okay. I detect there was another wrong. So let's go again with this one, okay? Because the problem was different. Let's go again with this one. So we said 2, 2 and 13, right? Mid is 2, right? Which is 12. Is 12 equal to 13? No. I'm starting from this part here. If you want to, let's go from the beginning. Okay, it was 9 and it was...
No, I understand about it.
So we're here. Okay. So now, okay, the element was 12. Is it less or bigger than 13? It's less, right? If it's less than 13, I should look on this side, right? Suppose they should look to the right of 12, right? So I have to go from mid plus 1. That's what the logic says. This was mid, right? Mid plus 1. So I should go from 3 all the way to the current end. The current end was 2, right? Correct? And now why you need it for later. It doesn't hurt to have it. So here you start saying, I have to keep searching from 3 to 2. Does it make sense? Can the left be bigger than my right? Doesn't make sense. Right? When I tell you search, I don't tell you from here to here. You expect this is smaller than this one, right? Correct? Well, the way you're looking from this angle will be from here to here, right? But if I tell you start looking from here to here, you're like, doesn't make any sense, right? You know what I'm saying? If I tell you like this, you understand that you have to start from here, right? But does it make sense to tell you that in all of a sudden tell you now start from here to here? Doesn't make any sense, right? Correct? Is that clear? Yes? I didn't even need this inside range. I did it for now. I might need it for something else later.
Leave it there when you're done.
I'm just covered. But you should tell me this case, I was looking for what? For 98, right?
Yeah.
Position is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Got it? If I put another position, say 188. We don't have that one, right? So the Java should say -1. I don't need inside range. I don't know when you guys make me doubt. Maybe confirm that. But anyway, now you know how to check for something inside range, right?
Yeah.
And R is 2, but where is that in there?
What do you mean?
R is 2, isn't R given that it's 2, or that's the length?
R is 2?
R is 2, always 2, it doesn't change?
No, this was for this example.
No, the letter R, how do you get a value 2 for the letter R in the code?
Here?
Yeah, where's the 2?
I will put in 2. The first time,
B that length.
okay, here I put 0 to 2 because I play with this small array.
Right,
But here I'm playing with a big array. Look, B. Look at the array B. It's long.
right.
So I'm just saying from 0, B length -1. First position to last position. That's all I'm saying.
Oh, it's there, that's where it is, okay.
Got it?
Yeah.
Is that clear, guys? Yes? Clear? Not really? Gotta practice and figure out.
Professor, quick question on that example, go back. Where do you get that meet equals 2 in the middle?
Here?
Yeah, where'd that come
You
from?
always say right plus left divided by 2. 2 plus 2 divided by 2 is 2.
Oh, okay,
Look at the logic here.
yeah, you go to that, okay.
Left plus right divided by 2.
Okay.
Right? Clear? Yes? So that's why you search. Okay? Yeah.
No, nobody's
Scared of the exam.
The recursion is tricky. I'm not gonna lie to you. It's not that simple. But